I'm going to go over the topic 2, derivatives, homework number 2. All right, so number 1, it says the function f is given by f of x. We have x cubed plus bx plus 6 times g of x, where b is a constant and g is a differentiable function. With these given information about the function and the derivative, for what value of b is f prime of 2 is equal to 0. So we see that there. I want to be able to involve f prime. So in order to involve f prime, I have to look to see, well, what can I do to find the derivative? To find the derivative, we see that these are 2 distinct expressions here. So we're going to have to go through a product rule because these 2 expressions are being multiplied with each other. So we have to go through product rule. And I'll treat the first part as f. And I'll treat the second portion as g. All right, so here's product rule. I'm going to lay everything out here. So we'll start off with f prime. We'll move to g plus f, and then g prime. Okay, so first up is f prime. Let's see, first term, x cubed. The derivative there is 3x squared. Bx, we're going to treat b like a constant. So imagine b was like a 6 or 5 or 8. If it was 8x, the derivative of 8x would be 8. So same thing here. The derivative of bx would just be the coefficient in front, just the b. The 6 is a constant. That's just going to drop away to 0. So that completes my f prime. Next up is my g function. No changes, so I'm just going to bring down g of x. Back to f. So the original expression that I see here. And then g prime. So the derivative of g of x, I'm just going to leave it in function notation. So times g prime. Right, so there's my derivative spelled out. Let's see, what information can we enter in? Well, let's see, we're asked to find f prime of 2. So let's go ahead and replace every x we see with 2. So 3 times 2 squared plus b times g of 2 going to do some cleanup. As I do some cleanup, I'm also going to insert values that are given to me. G of 2 equals 3. I'll make that insertion. G prime of 2 is equal to -1, and then f prime of 2 is equal to 0. So I'm going to clean up and make substitutions at the same time. So a couple things I can replace here. I'll replace this portion, replace that, and the hope is that we can get it all the way down where the only thing missing is our b value. We can solve for b. All right, 3 times 2 squared, 3 times 4 is 12. G of 2 is 3. 2 cubed is 8. G prime of 2 is -1. Let's see. All right, so I'm going to solve for b here. B is my only variable left, so I should be able to isolate it and solve for b. I'll distribute the 3 through. 3 times 12, 36. Distribute the 8 through, I get minus 8, minus 2b, minus 6. So 36 minus 6, minus 8, 22. 3b minus 2b is just 1b. And then I can solve for b here. Subtract 22 from both sides. Negative 22 is equal to b. There's my answer. All right, number 2, differentiable function. So smooth curve all the way through. It says b is defined as f times g. So we want to find f. We want to find b prime of 2. To find b prime of 2, we see that these are multiplied together. We have to involve product rule again. So f prime times g plus f g prime. All right, so I'm going to just spell out my derivative here, and then I can worry about the 2. All right, replace every x we see with 2. So now let's see what information we can gather from our table. F prime of 2 is 3. G of 2 is 1. F of 2 is 5. And G prime of 2 is negative 2. Okay. All right, so we're just replacing each of these values with what is given to us in the table. Clean this up here. Negative 7. Part B, our function is m of x is defined as f of g of x, then m prime of 1 is equal to. We need to recognize that this is a composition function. There's a function within the function. G is inside the f. So if I want to find the derivative, I have to go through chain rule. Okay. So we have to first find m prime of x before we can even deal with what to do with that 1. So here's a reminder of chain rule. Outside function's derivative multiplied by inside function's derivative. So if I want to find m prime of x, I can rely on this rule here. My f and g is already defined here. So we can say m prime of x is equal to f prime of replace every x we see with 1. All right, so we're going to work from from the inside out here. We're going to first find that g of 1. Once we find g of 1, we can have more information to actually figure out what to do with this larger portion, that f prime. So I'm just going to replace that g of 1. I know g of 1 is equal to 3. So I'm going to copy everything else from my problem, just going to make that substitution there. So I replaced 3 in for g of 1, and now that makes it a little bit easier, more straightforward as to what's going on here. So now the remaining part is I need to figure out what f prime of 3 is. So f prime of 3, we go back to our table here. F prime of 3 is equal to 4. And then g prime of 1 is negative 3. All right, number 3, our function is defined as e to the 2 over x. Then we want to find f prime. There's two things going on here. We have to first identify that there is a need for that e to the u rule. So let me write that rule here. E to the u is just e to the u times u prime. There's another rule that we have to involve, and that's going to be power rule. So that 2 over x, we have to rewrite it in a way where we can apply power rule. And power rule is just bringing down the exponent and subtracting 1 from the exponent. But before we do power rule there, we have to get that 2 over x to be the proper form, right? So one of the conditions for power rule is we can't have variable in the denominator, or we have to rewrite it in a way where that variable is in the numerator. So I'm going to rewrite the problem here, f of x. E to the 2 over x, the same thing as e to the 2x to the negative 1. So I'm just bringing the denominator of the exponent to the numerator to make it more suitable, more ready for our next step, which now we can apply using power rule. So, but first things first, we need to take care of that e to the u rule. We can handle that exponent when we get to it. So the rule for e to the u is just e to the u. So the derivative is the function itself. Times the exponent's derivative. So I've rewritten my exponent. So I'm going to go through power rule to handle the exponent's derivative. Bring down the negative 1. So negative 1 times 2 is negative 2. And then we subtract 1 from the exponent. Negative 1 minus 1 is negative 2. So here's our derivative. We just want to do a little bit of cleanup so that we can actually find the appropriate match with our answer choice. I'm going to bring that 2x to negative 1 back to 2 over x because I see that is what the answer choice is, bringing it back in terms of that. And if I do a little bit of cleanup here, I should be able to get that to match my answer choice D. All right, number 4. Says find y prime. This is natural log of e to the x over e to the x minus 1. We do have a rule for natural log, which is the derivative of natural log of u is just u prime over u. But whenever I see a natural log problem, I'm always trying to decide, is there anything I can do so that my derivative process can be a little cleaner? So we have log properties available to us, so we can expand. So if we expand our expression, we'll have an easier time of handling the derivative because we can break a messy problem into smaller ones. So we have expansion property here. So the rule is if I have natural log of a over b, this is not a derivative step, but it's just an expansion step. I can rewrite it as natural log of a minus natural log of b. So if we rewrite this problem into easier, smaller pieces, our derivative step will be easier. So rewriting the problem, y equals, my a value is e to the x, my b value is that denominator, e to the x minus 1. So I have natural log of e to the x minus natural log of e to the x minus 1. Okay. So there's our equation. We'll have an easier time with its derivative. Now I'm looking at this here and I'm saying I can do even more cleanup here, right? We have another property, which is power property. I can bring the exponent down within a natural log expression without impacting or changing my overall value, but maybe it would just make things easier for me to work with. So I'm going to keep expanding here, bring that x down in front. And if I bring that x down in front, I see that, oh, there's something I can do to clean this up. Natural log of e is just 1. So now I'm just left with x minus natural log of e to the x minus 1. And this I can use power rule, and this I can use my u prime over u. X becomes 1, u prime over u. So my u value is the portion inside the parentheses. So the derivative of e to the x minus 1 is just e to the x. That's the derivative of e to the u. It's just e to the u times u prime. All over my denominator here. Now I have my answer, but I wanted to match with one of my choices here. So it looks like if I can get a common denominator, I'll have a better chance of matching my answer choice. So my common denominator is e to the x minus 1. So once I'm able to match that denominator, I can combine the numerator together. So e to the x minus 1 minus e to the x. I can get the e to the x to go away. I'm just left with negative 1 over e to the x minus 1. Answer choice C. Back page, number 5. It says if a point moves on the curve given by x squared plus y squared equals 25, given the order pair 0, 5, find d2y over dx2. So that's just a notation for us to find the second derivative. So if I want to find the derivative where I have y mixed into my equation, I know I have to involve implicit differentiation. So we know we're going to be expecting some dy dx's along the way. Okay, so we're jumping into our derivative step here. Each term, we can apply power rule. X squared becomes 2x. Y squared becomes 2y. But because we're involving y's derivative, we need to attach a dy dx. And then the 25 is a constant, so that's also getting impacted. We'll make that 25 go to 0. Right? I'm going to solve for dy dx, and that will be representative of first derivative, and then we can talk about how to get to that second derivative. So I'll subtract 2x from both sides. Divide both sides by 2y. Clean this up. So I'm halfway there. My derivative is negative x over y. Now I want to find the second derivative. Now to find the second derivative, I'm looking at this and I have to decide, okay, I got to go through quotient rule because I have numerator and denominator, and I've got to go through another set of implicit because I have y's involved in my equation. So go through quotient rule. So dy dx becomes d2y over dx2 because we're now ready to find the second derivative. And let me identify quotient rule here. So quotient rule here, we have f prime times g minus f g prime all over g squared. Okay, so the numerator is the f, denominator is the g, so f prime, the derivative of negative x, is just -1. The g function remains as y. Back to f, negative x. And then g prime is y's derivative, so the derivative of y is just dy dx, 1 dy dx. All over my denominator squared, so my denominator is y, so y squared. Okay, we need to be able to enter in a value. We have a replacement for x's and y's, but what to do with that dy dx? Well, if we look, we have something that can represent dy dx, right? We have that negative x over y. So I'm going to insert that negative x over y into that dy dx and see if I can get this a little bit cleaned up, and then I can enter in, replace all the x's and y's with 0 and 5. So I'm just going to make a simple replacement here, dy dx, replace it with negative x over y, and all over y squared. All right, I think I'm ready now. Replacing every x and y with 0 and 5, and that should allow me to get to the value at that second derivative. So replace x with 0, replace y with 5. X times x, so that's 0 squared over 5, all over 5 squared. We know the 0 and 5 is just going to go away, so that's not going to be a factor here. So negative 5 over 25, which reduces to be negative 1/5. All right, number 6. We have the graphs of functions f and g shown. H is defined as this numerator portion divided by this denominator portion, is asking for h prime of 3. So before we can find h prime of 3, we need to find h prime of x. To find h prime of x, we see that we have numerator and denominator involved. We're going to have to go through quotient rule. maybe I want to work this out on a separate sheet just to give myself more room here. Okay, so here's number 6. Right, I want to go through quotient rule. I'll treat this entire numerator as my f, and I'll treat the denominator there as my g here. So, quotient rule. All right, let me spell out each of the parts. All over g squared. All right, so f prime, the derivative of my numerator, f becomes f prime, 4 goes to 0, so just f prime. G function, no changes. I'm just going to copy that down exactly as I see it. Back to f. G prime, so the derivative of my denominator there, so g becomes g prime, 2x becomes 2. All over my denominator squared. All right, so there's my full derivative. We want to find h prime of 3, so I'm just going to go ahead and replace every x I see with 3. All right, we need to rely on our table to help us find our replacement for all these values that are stuck in function notation. So we need to find f prime of 3, we need to find f of 3, we need to find g of 3, we need to find g prime of 3. Okay, so let's go to our graph here. So we have everything here is involving 3 here. So we're either going to be asking for our ordered pair at these graphs, or we're going to be asking for the slopes at these graphs, because prime represents slope. So let me highlight those points there. F of 3 is here. And we say f of 3 is simply going to be 4. I'll put that up here. Now, f prime of 3 is asking for the slope of the graph at that point. We see this point as part of this line, so if I can find the slope of this line segment, I know the slope of the graph at that point. So if I can just pick 2 points along this graph here and just do rise over run. So I pick another point here. I see this is a positive slope. Rise over 1, up 1, over 2. So the slope there is 1/2. So if that's the slope, I can then say, well, that must be f prime. F prime of 3 is equal to 1/2. This line segment has a gradual slope of 1/2. Now on to g, because I need to find g of 3 and g prime of 3. So I'm going to highlight that point there. G of 3 is here. We see g of 3 is just a y value of 2. And then g prime of 3 is just going to be a slope of the g graph along this line. I'm going to pick another point here, and this is going to be a negative slope. I'm going to have to go rise over 1, so down 3, 1, 2, 3, over 1. Down 3 over 1, that's negative 3. All right, we have all the values that we need. We're going to replace all of these into my expression, and then I should be able to get this down to a numeric answer. F prime of 3 is 1/2. G of 3 is 2 plus 6. F of 3 is 4 plus 4. G prime of 3 is negative 3 plus 2. All over G of 3 plus 2 squared, so that's 2 plus 2. Squared. Continue cleaning up here. 1/2 times 8 minus, this is 8 times negative 1, all over 4 squared, 16. So I get 4 plus 8 is 12. Which reduces to be just 3 over 4. Let's see here. G of x plus 2. Oh, okay, I messed up here. I did not copy down my denominator correctly. So it should be g of x plus 2x. That's going to change things a little bit here. So my x is 3, so 2 times 3, that should be a 6. So I have 2 plus 6, that should be 8. And then 8 squared is 64. And then 12 over 64, I can take 4 from each of those terms there, so I have 3 over 16. Okay. Answer choice C. All right, number 7. We have a differentiable function, h of x, defined by this expression here. Which of the following is h prime? All right, this is going to be a series of chain rule here. We have a function within a function within a function. So we have to recognize the need for chain rule. So I'm going to rewrite this using bracket to help us see the various parts that are within each of these terms here. I'm going to use a bracket here to represent the outer portion. So my outer portion is that bracket squared. The next function in is 1 plus f of parentheses, and the innermost function is at 3x. So I'm going to identify each of them here. We have the outermost portion being that bracket squared. The next portion in is that 1 plus f. And then finally, the innermost portion is that 3x, which is going to take turns with each of their derivatives and place them all in their own space apart from each other. So h prime, outermost portion first. So bracket squared, we go through power rule there, bring down the 2, keep the bracket, subtract 1 from the exponent. We copy down the exact problem from before, no changes inside. Times inside function's derivative, so we got to find the derivative of 1 plus f of parentheses. So 1 goes away to 0, and then f just becomes f prime. And we insert into the parentheses the original inner, multiply by the innermost function's derivative, so 3x becomes 3. So we have a derivative for each of our 3 expressions, and they're all in their own separate space. We'll do a little bit of cleanup. I can push the coefficients together, 2 and 3. But looks like this is already matching my answer choice. So I'm able to just, there's no need to rearrange. I can just see that this is matching answer choice D. So I can just stop at this form. Number 8 is demonstrating this relationship between a function and its inverse, as well as their derivatives. And I like to go through a chart to kind of help map my progress here. It says the graph of a decreasing differentiable function is shown. As shown, we have a tangent line to the graph of f at the point 4,6. Let g be the inverse of f. Which of the following is true? Okay. So we know that our order pair is at 4,6, but we're trying to find a g prime of a value. So this is the chart that I like to go through here. My ultimate goal is to find g prime of a value. But I know that f of x has an order pair of 4,6. And I know that order pair between my f and g are always going to be flipped. So if my order pair for my function is 4,6, I know that for my g function, it must be 6,4, right? That's just the relationship that we know between a function and its inverse. So ultimately, we're trying to find g prime of 6. Right? That's the x value that is that corresponding point for our function. So the relationship here is if I can find the slope of the graph at 4, then that slope is going to lead me to, I can adjust that slope to figure out the slope of the g graph at 6. So let's see. We have the graph in front of us for 4. If I can find the slope of this tangent line, then I can use that slope to figure out the slope of the g graph at 6, even though we're not seeing our g graph at all. But we're making that leap from the information that we gather from our f side of things. So this is showing us clearly what the tangent line is. So if I can find the slope of this line, I know the slope of the graph at that point. So the slope of this line here, if I can just find another point, I can just do rise over run. So I'm going to go searching for another point on this graph. I think I find a point here. Here's one that crosses at a nice intersection between the grid. So rise over run, I'm going to count down 3 units. I'm going to count over 4 units. So there's my slope. My slope is -3 over 4. So if my slope is -3/4, then I know g prime of 6 is just going to be the reciprocal of that. Don't change the signs. It's not opposite reciprocal, just reciprocal. So -4 over 3. answer choice C. All right, see you guys at the next review.